Okay, I'm on page 197 and I'm looking at example 4. And the question is the function in the graph linear? So the first thing we want to do is test to see if we have a function. And I'll do this column. All of the x's are different, so yes, we have a function. Now let's see if it is 1 to 1. So to know that, I'll look at the y's, or the f of x. I should have put there, but that's okay. Yes, it is 1 to 1 because all of the y's are different. So now we need to calculate the consecutive differences, and that will tell us what we need to know. So here's this column. Remember, a linear function will be common at the first degree, at the first level. So we have a 0 minus a 1, that's negative 1. What am I doing? Sorry, guys. How about a 1 minus a 0? That's a 1. And then a 2 minus a 1 is a 1. And a 3 minus a 1 is not what I need. It's 3 minus 2. That's 1. And 4 minus 3 is 1. So it is common at the first degree. Is it a linear function? No. And you say, whoa, why not? It's common at the first degree. So what's the problem with this one? Look at your x column. 1, 10, 100, 1,000, 10,000. The x values are the problem. They are not consecutive. They're not in order. They're not 1, 2, 3, 4. They're 1, 10, 100, 1,000, 10,000. Be careful here. Just because the consecutive differences appear to be the same, the problem is this. It's not consecutive. It's just differences. But the x values are not consecutive, and therefore the differences are not consecutive. Okay, so be careful. If they wanted to, they could really mess with us here. So we have to check each of those conditions. You have to check your x values to see if it's a function, and while you're there, check to see if the x's are in order, if they're consecutive x's. That's a very good question. In my opinion, it's a trick question, but it's a good one.